Добрый день. Ну что, наверное, начнем?
Greetings, everyone. I think we can start. So, yesterday we had... My name is Frolkov Ivan. I am presenting Postgres Professional, and I will tell you about how it is possible to send transaction to Bitcoin from Postgres Pro. And you can not only send transaction, but still you can... everything is just similar, and this is from one side. And from the second side, I want to tell you about scheduler and about the problems that we can solve by using Bitcoin and the daemon Bitcoin and its PCIP. Actually, these problems are arising not only with Bitcoin, but with Bitcoin they are very characteristic, and they are not the primitive ones. But of course, it's not the hardest case. So our aim is to send transactions to Bitcoin, actually to its blockchain. And when I, with my colleagues, have told that I will tell about this, they just asked me to explain what Bitcoin is, that Bitcoin is nothing. I'm not speaking about significance of Bitcoin, but your aim is to have the knowledge to receive the Bitcoin payments independently whether you think Bitcoin is feasible or not feasible. Have you worked with Bitcoin PCIP or something else? Nobody of you. Very great. Perhaps not so great, but still. Bitcoin blockchain can be of two types. There are two blockchains, the live money blockchain and blockchain that is only used for debugging. And we will speak about the testnet, the second type of Bitcoin for debugging. If you are interested, you can install the corresponding daemon, use it in the regime of testnet. It will start the blockchain for testnet. It's a small program, and it can be downloaded in minutes. So it's just for your play. And this is the play I made. So when I started, I did not have anything from Bitcoin. What is Bitcoin for the developer, applied developer? And this is the knowledge that applies not only to Bitcoin, but the developer can work in two ways with daemons. This is REST-DI, and you can use this link to take a look at it. And Roskomnadzor had blocked one of the pages with Bitcoin, and some of providers can block it. But I think you can find a link to take a look at this documentation. I don't know what was so terrible in it. And the second mean is you can use command prompt, and it will fall into Bitcoin Red IP, so you can take a look at it or make something there. You can check your balance, create a new address, and I will tell you a bit later what address in Bitcoin is, and send some queries. To understand what I will do, I decided to speak for some time about the explanation of what blockchain is and how does it work. Blockchain is the line of blocks. Block 1, block 2, block 3. Block is a majority of transactions. The blocks are created consecutively, and transactions are inside of the blocks. Transactions, this is just a set of transactions. One of the miners finds some significance for them, and this significance is not interesting. The value is not interesting us, but we can characterize any transactions in blocks. Now we have more than 600,000 blocks. Blocks are collected every 5-7 minutes, and it was nearly 10 minutes. 1,600 blocks are passed in one day. And when miners finds a block, he sends it to blockchain, the other daemons. see this block. And if you install daemon, you can ask to mine, but your daemon will then eat up your processor. Please don't use mining on your daemons, because it will eat all of your processes. So if your daemon receives a block and adds it into blockchain, you can receive one correct block. It is Verstellung. This is a very important moment, and there can be many of them on one level, and I have seen only 2 branches of them, but still it happens. The daemon receives blocks, and out of 2 possibilities, it will choose only one, and actually it works very well. But still, if we received a block, it is not a fact that it will stay on its place. Of course, it can happen, but still, many operations require only one proof, but you can wait a bit later for it if you are working with high loads and comparisons. The maniacs are waiting for 6 repetitions for old blocks, and it took for old blocks some about 1 hour. We can take one block now for 5 minutes. It really depends of the commission that you installed in transaction, and it can wait for a really long time when you... So what is transactions? Transactions are the entrances and the way out, way in and way out. Transaction consists of a script, and all Bitcoin operations are performed through scripts. The language is Fort. It's a primitive language. It has no cycles. It has only branches. So I just want to tell you that there are cycles in Ethereum, but here all the scripts are built in one standard transaction. I would also like to mention that we're now accepting the idea of a light network with tricky scripts and the addresses when the transaction is supported by many parties, by several parties. It can be also convenient. And the limitation is that way-ins equal to way-out. So every transaction should be followed. That means if you have 1 Bitcoin and you wanted to upgrade for someone 0.5 Bitcoin, that means the entrance, the way in will have 1 Bitcoin on its address, and the second will be your address, so the address of way out. As I already told you, the way ins and way outs are addresses. It's a couple of 2 keys. But the transaction is not the key itself, but it's a hash. Hash is not so long as an open key, but you can also install open keys and the control sum. You just cannot create an address in your head, or if even you will create it, Bitcoin won't work. This is a great invention because it helps you to fight against typos, and it's not the same as in Ethereum, because you can send Ethereum in every way, but here it's another case. Here's an example of an address out of the normal network. It's a normal regular Bitcoin. The first digit is 1. That means it's just a regular address. It can be also 3. The seducer address and some others. And in the end, you can find the control sum. The coding of addresses is made according to base 58. You can Google for it or look for it in Wikipedia. And I would rather recommend you to take a look at it because it's a very great tool to identify identificators, and these are accurate sums. And because we are working with base 58, 0 and O cannot be crossed or interchanged, and they're more convenient for us just to see them on screen. They're convenient. I like them actually. as an identificator with no connection to Bitcoin or else. The same principle is applied in Bitcoin, not only in Bitcoin but in Litecoin. It's a clone of Bitcoin and the open source of Zcash. And Zcash is very interesting. I think you could also take a look at it. So what happens with transaction? How does it go to blockchain? When you send your PC IP to the daemon of your transaction and ask to execute it, it comes not to the daemon, it comes into midpool. Midpool is a list of transactions that are ready to be sent to blockchain. The miners can find appropriate transactions with highest commissions, and they pick them up. So the higher commission is the better is it for the transaction. Transactions can wait for the realization for 24 hours or even more. I have seen it by my own eyes, and this is very important because you need to understand this. Transaction has the transaction fee. If the higher transaction fee is, the higher is the speed, and there is also an identificator. It is way in, way out, address and script. It has a unique identificator. They are not using base 58, but they're using 6-digit forms for identification of transaction numbers. So I have seen the blockchain info. It is a kind of explorer for blockchain where you can take a look at transactions, what happened with transactions. So I took one of many blocks and one of transaction from the blocks. This is the shape of transaction. If transaction comes into DBeer, it can have thousands and thousands of way-ins and ways out, although transaction can be very small. And if you will write some readers for blockchain, it's not a complicated thing, but you need to understand that your address can be found in way outs for several times. Please pay attention to it. Actually, we can see that the entrance, the way-in is for one transaction is 334 BTC, $21,000 for now, and you can see the addresses of its distribution and the sums of the distribution. It's impossible to say whose address you are seeing at, and you can only build a chain of addresses, but the whole list of addresses cannot be created. So the log for Bitcoin does not know all the addresses that it uses, and it can be many of them. What is the Bitcoin wallet? Wallet is a unity of addresses with closed and open keys. The pairs of addresses are not combined or interchanged. They are not generated, and I think we just cannot see the combination of them as a thing like deterministic wallets. And in a key phrase, you can generate many addresses. They are generated. You need to check every address for its consistency with your or other bases. So if you will work with bitcoins, it is a very interesting topic. For the outer exploration, this data is not combined. You cannot see out of transaction who sent the Bitcoin. You could send it to yourself. You can send Bitcoin to many way outs. So there are many organizations who want to distinguish, who want to know the data, but I don't know whether these data are true or false. There are also anonymous operations provided by Zcash, but this is not the topic of our today's discussion. As I already told you, all way-ins must correspond to way-outs, and you must utilize the way-ins that were not that could not find their way-outs. Like half of bitcoins could go out through way-outs, and you can find in your wallets the addresses of provision. So there are many of them. You can not have even one bitcoin, but a part of it, and you can distribute the parts of Bitcoin through the corresponding transactions through your wallet. Everything is great here, but in the end we face a problem, because Bitcoin and the blockchain was written by clever guys, by the doers, but speaking about database and business operations, they had not so much knowledge in this. Now I will explain why. Bitcoin has the RPC, that is like RPC of Litecoin, and by USI Cash, the Ethereum has the similar UPC, but it's a rather strange thing. I think Bitcoin is created in a more clever way here. These are examples of calls from lists of transactions. You could get your list of transactions in your wallet. You can send sums from one locally address to the other one. You can distribute Bitcoin to many addresses and reset to address. And it distributes the sum from its own addresses to one specified address. There is a sum on address that should be not less than commission for a transaction. It could be a very high one. So let's take a look at the parameters of the function. Address, sum, comment for you, and transactions fee calculated out of amount. How do you say? It's a great function, a good function. Can we use it? Do you have any ideas? The problem with this function is that we don't know what shall be done if we don't receive any answer. That means you say command to put in and put out. Something happens, and it can vary. It can vary. You can fall. Your network can fall, or you just don't receive any answer. So you don't know what happened with the transaction, and we don't know what happened with it. The same problems can arise not only for Bitcoin but with many things. This is the non-cancelable operation. If you send a print command for your printer, and if the printer is not online, you don't understand whether the printer printed something or not. The same problem can arise for ATM. If the ATM gives you cash and there is some fail, you won't understand what happened in the end. And this is the hardware limitation. So with printer and with ATM, for their physical entities, it's hard to work. But when we work with Bitcoins, yesterday I told about one bank that works with XMLs, with the accounts, with the IBAN accounts, with the bank identification code, and with the commentary. So that's all. If I mistakenly send two of them, they will pass through the way out. And this is the same situation with Bitcoin. So apparently they could add one more identification, and then we could cope with it. But actually this identification is in Bitcoin, but it's not realized. There is a call for IP for sense of transactions. The transactions are sent as a whole with way in, way out, hash scripts. So where did they get the transaction? There is a call for create transaction, and you can receive a massive of way-ins with addresses, with links for the addresses that were shaped on the addresses. And the problems arise. If we will do this, we need to follow all the sums on all the addresses that we have, and in Bitcoin it's not a trivial thing. And afterwards, when we collect all the addresses, we need to cope of who shaped the addresses, and we can make many mistakes here. So it's not effective. It's a low-level architecture. That means let us send Bitcoin through CM2 address it's the idle potency, the impossibility of secondary repetition. If you work with wall, if you perform any operations with wall, it's a very great thing to introduce limitations for potency. You just can add some additional attribute, and it would be a very great thing to limit the system for entering twice of such attribute. It's a very good case for financial operations to not execute the same operation. It's not realized in Bitcoin, therefore I would like to criticize this part of Bitcoin. So there could be also virtual DB that is inside of Bitcoin. It's a base, non-SQL database, so it's very interesting and comprehensible thing. You cannot cancel this operation. Frankly speaking, you can cancel it. It's theoretically possible to fight against the transaction if it is placed in mid-pool, but there is also blockchain like Wave produced in the Russian Federation. In the Russian Federation, I think not everyone knows about this, but this kind of blockchain can create transaction and send it. So I think it's just not passing through, and I think this is not a regular case for us. I don't know what was their motivation. So what will we do with the sending? Please do not sleep. I hope it's not so boring. So what we will make with the sending of Bitcoin? The first step is a rather modest one, the blocking of payment. Why am I speaking about this? Regularly all payments are sent as tables that can be edited by someone, where you can edit the stage of the payment. And when you need to provide way out for a payment, you just can mark it as the appropriate. If there are many streams for it, we can make this way out several times. If you start to put it out, if you see the state of ready to be put out, if the transaction is good, we just mark it as the transaction that is put out. So this is the stage of the transaction of what is done. Afterwards, we start to put it out. We can send transaction in two ways. It can be successful or unsuccessful. So successful transaction is not interesting for us. So the transaction left us. That's not a big deal. An unsuccessful transaction can be created by interesting means. We can have end timeout and refuse of message. We can meet timeout at the receiving of the answer. We can have a business stage that we have, like imagine we try to send a Bitcoin and we have zero, we have nothing. And this moment I would like to explain this moment. Imagine you have one Bitcoin and you have two claims to create two bases of 0.9 Bitcoin. The situation may be very interesting. All the transaction, both of the transaction can be traced, but then in the end one transaction is dead, or it can happen that only one of the transactions will find its way out. So if the transaction has made its way out, it can be stored not so long in mid-pool. They can get rid of the transaction. But still, if the transaction is in mid-pool, if one transaction has a mistake, the mistake can be of two types. Either you don't have enough Bitcoin in your wallet, or no route to post, or no route to the end user. What is the characteristics of the transactions? You can rerun the transactions. There are also other mistakes that cannot be altered because of the architecture of Bitcoin. Actually, it's not the typical situation for Bitcoin. It's a rare situation, and it happens when your machine is highly loaded. And it can also happen during the timeout, but it's a rare thing, rare case. Still, it happens. So, in case if you have an irreparable mistake, if you have seen this mistake, we go through reparable TCP/IP. We work with JSON, and JSON creates an HTML, and this page is not existing still. We can repeat this operation, and this operation is not requiring too much energy from your AI. So the applications that work with money should be robust. You cannot create. It is better than to not perform a bad operation than to perform it as a half. So, speaking about the mistakes, many of us start to be very responsible people, or seem to be like them. Of course, we can work with high sums, and it's better to be broken on every mistake. So, if we receive unknown response, it's better for us to recreate the system by means of other programmers. If the transaction passed great, we need to wait for a certain amount of received information, and then we wait for a proof. We can wait for 1, 2, and if you have paranoia, you can wait for many of the proofs. So it all depends on you. If you receive the proof, you can make something, and if you receive the error mistake, you can also make something. So now we will work with the management of these stages on the basis of PG Pro scheduler. So I represented it as a tree, and every task is depending on the previous. So that means we cannot restore the system or unblock the state when we step through two procedures. So this is a tree. Actually, list is also a tree, but it is a bit degraded. Now I will show you the code. So Andrei left, and I think I will just sit here.
Работает хорошо. Итак, мне вот тут Степан.
So, Stepan collected on the virtual machine the software which is related to this topic. I will show you what it looks like. The database which we will work with. For such projects, I usually use the files which are compiled in SQL and then put into a database and processed it there. For the database, it's better to create a separate script so it can work together. We will need log. We create the log. It's quite a simple option. And also rev as a source which created this entry. For execution of our tasks in PGP Pro scheduler, the table with parameters, it's called job params. There is a key describing the parameters and JSON where we can put anything we need. We have transactions. Transactions have conditions, and I'd like to draw your attention that transaction can change conditions, and I saw it many times when we have an object and a certain condition, age, weight, job, or anything else. And in this database we can switch between conditions. We can, for example, change sex from male to female, and it works fine in the database. But actually this is not very good. As I've said, that application should be fragile and should not allow such simple changes. Basically we have conditions table with a code, with the primary key and previous condition in which the entity should be, and here is an example. We can get there from the beginning. This is from pending, and in case of failure, back to pending condition, and this all enabled by trigger. Why do we need this? If, for example, you decide to switch the condition, not send, and by mistake you will create a few thousands of such objects. It will be quite sad, and if you block this, then you will remember about my presentation, because it happened to me once in the past due to certain reasons. We have transactions table. It's quite simple. Operation ID, condition, transaction condition. Please pay attention that we don't use it that often. This is a foreign key, deferrable initially, so it's checked in the end of transaction. Sometimes we need it to make a cycle reference to whom it's sent, transaction ID, sum, notes, and the last error. And also there is a trigger. Here we can see if we add something, the previous conditions should be in the list of requirements. Also, I like to put some exceptions. Here I put them as well. Does anybody know how to work with keys in Postgres? Just one person. Two. Well, basically, as you two can see, I eliminate exceptions. CC0102. If somebody is trying to create a table and gets these exceptions, then in the comments to the table you can write all those exceptions. And basically, this is it. I create a trigger from this function, and then we move to the message sending function. Message about transaction. The keyboard is not convenient. So this is the function which will send. From the top I took an example of its calling. Which parameters does it have? Address where we send it, the sum, callback for successful sending, and callback for unsuccessful sending, because it can be sent for some time, for a few days, for example. And we cannot wait until it will finish its work, so it should be synchronized. Callbacks are quite silly, they just inside the message with parameters, and then everything ends. So again, I repeated the list of operations which happen. We block transaction, we perform the actual sending, and then we look at the results. We're waiting for confirmation, done, or we get error, done. So each one of these lines, it's a one-time job in the Pro scheduler. To send, to analyze the results of sending, and then based on the result, we either wait for confirmation or somehow mark that it cannot be restored. This is address where we send it, the amount, and the callbacks. And if any job which we submit in ProScheduler. After connection is established, we can look what happened with it in the table. I didn't indicate the table here, but if you're interested, you can look into the documentation. In order that we can drag the information through the chain of operations, we need a common key. I generated here. It depends on timestamp, and it's unique. Parameters for the calling. And next, this function consists of declaration. First, we declare that blocking function for the transaction. As a parameter in query, we can reference to these parameters by their numbers. So here I refer to param. Also, it's good to give a name to the jobs, so it can be easier to understand what it did. Otherwise, it will not be very visible. Also, we can put notes. Here, I usually put reference which we created there. So we have calling, sending identificator, blocking. Next there is ID of sending, log payment. I don't know if I will show you all of them, because mostly they're quite simple. If you do such things, I would recommend to start with writing of functions and after to perform debugging. This sequence is better. Create function first, and then we compile the list of jobs for sending. So we create the first function, the actual sending. There is this parameter, depends on. It refers to the other parameter. This is blocking of entry for sending. So the first function will be executed, and then the other. Next is waiting for results, required number of confirmations, and then in case of execution with an error, we can just indicate a usual query to give parameters and other things. A little bit below I will put that they are infinite. Job result selector also depends on send. And also calling in case of successful execution, and callback for unsuccessful execution. We clean up everything after, and it cleans all the jobs. We need parameters which we will modify and put it in the table. The code is quite simple, and here I put that two jobs should wait indefinite time for execution. Here's the function log payment. It's very simple. It just inserts a line in transaction table and gives identificator to this line. And logger also writes what happened. This is sending function, which is a bit more complicated. We need transaction ID entry line which has been executed, and a flag which shows us if there is an error, it can be eliminated or not, or it just cannot be fixed. For sending, I'm using this module, PGSquare HTTP. This is where I got it from, if you're interested. This is just a regular shell. However, it exists, it works, and if you need it, you can use it. Also, there are wrappers, but this one I like more, it's more logical. So this is our function. We write in the log what we are going to send, and then we compile the query for output. These are headers, body, status. We're more interested in the body right now. It's parameters, method, address, headers, request type, and body. Here, a request is generated for Bitcoin, and also parameters, address and amount. If the result is okay, then we can proceed. Please pay attention to JSON. I cannot say that it's very convenient, but it works quite well. If we look higher, and if there is a mistake, for example, not enough funds, we give an exception with such statement BT001. If we got a number of transaction ID, then we update the parameters, we write the transaction and update the condition. If it didn't work out, then we send a new exceptions and write it in the log. Processing of exceptions is very important. Unfortunately, HTTP module for errors, it gives only one type of message, and it's very difficult to understand what happened based on this message. This is just something which is not convenient, unfortunately. Here I had an error, connection timeout. Maybe somebody knows what is the difference. Okay, so if we have an error like failed to connect, no route to host, connection timeout, then we can try to do this operation again after some time. If it failed, then we don't know what happened, and we are writing that we will not proceed. BT001 means that not enough funds, so we can put try again later. Some other details in case of other errors. And accordingly we set parameter as it was. We write in the log, and to resubmit it in 15 seconds. And if some unknown error occurred, then we stop work and everything stops. Let's try sending. I have a prepared query. I will send it to my phone. Maybe it will come fast, or maybe later. It can take sometimes up to 1 hour for delivery. So we sent it. Let's have a look what happened in the log. Transaction sent. Now we're waiting for confirmation, or I can send it with an error right now. We can look what happened. My phone I cannot show to everyone. So, look, it was sent, confirmed, transaction was successful. That's how it works. Let's try to modify the code and our transaction will fail. Which option you like more? Let's try connection refused. Now I'm trying to send it. And where did it send it? Interesting. I didn't recompile it. Okay, let's send it again. Okay, now we sent it again, and it should be pending. Yes, there is an error. Connection denied. Unfortunately, it writes it in Russian. So what can we do? Let's simulate the correction. So it failed 2 times. From the 3rd try, it sent. So we can play also with other parameters and it will work like this. What else can I say about it? It's actually quite convenient to process such errors, because if something doesn't work, then when everything comes back online, it can fix itself and you will not have to intervene. That is all. Do you have any questions? This is version 9.6, 10.0. To localhost, Bitcoin. Yes, of course, in testnet. Yes, of course, there is a blockchain. This is not related to the keys, and actually your blockchain wallet can be under password, or you can unblock it. And if you set a password and login in config, it will grant you access to your wallet. So there is blockchain. This is the username, password, localhost port, and that's it. It works. Well, thank you.